Section 2.7a, graphs of rational functions. So what we did yesterday in section 2.6 leads us up to actually using that information now to produce a graph of the rational function. So much of what we're going to do today is going to be exactly the same. We're just adding in the graph to the information we did yesterday. So the first thing we want to do here in looking at this function is list all intercepts, holes, and asymptotes. Well, we begin by seeing if anything factors. Nothing factors here, which means no terms are going to cancel, which tells us right away that this graph has no holes. Asymptotes. Vertical asymptote and horizontal asymptotes we need to find. Vertical asymptote, we take the denominator, set it equal to 0. We're going to have a vertical asymptote at x equals 2. Horizontal asymptote, we have a degree 0 polynomial in the numerator, degree 1 in the denominator. Numerator is less of a degree than the denominator is, so that tells us that our horizontal asymptote is going to be at y equals 0. X-intercepts. X-intercept, we set the numerator equal to 0. Nothing to solve for there, so that tells us this graph has no x-intercepts. Y-intercept, we plug in 0 for x, we get 3 over negative 2. So there is our y-intercept. So let's begin graphing here. Start with our asymptotes. We have 1 at x equals 2. We have another one at y equals 0. And now we have a point at, or y-intercept at 0, negative 3/2. And that's the only point we know. That's not enough points for us to complete our graph, so we're going to have to make an XY chart and pick another point. Now, when you're picking points, you are picking everything in relationship to where your vertical asymptote is. So in this case, to the left of the vertical asymptote, I already know we have a point down here. Our rational function is going to be a smooth curve approaching the asymptote lines in both directions. Now, to the right of that asymptote line, we're not sure whether our curve is going to be down in this bottom portion or up in the top portion of our graph. So pick some value to the right of that asymptote line. If I plug 3 in for x, we get 3 over 1, or 3 out for y. So I have a point over 3, up 3, which tells us to the right of this asymptote line then, we're going to have a smooth curve approaching both asymptote lines up in that section. And that is it for our graph. So once you know how to do all the information we talked about yesterday, that's basically everything you need to do. You're just using that information now to sketch the graph. Again, the asymptote lines drawn in red there are not actually parts of the graph. They're just lines that the graph approaches. That helps us give a little bit more accurate picture. You must have your asymptotes plotted. Otherwise, it looks like your function does not approach those, but it's just going to keep on going forever in all directions. So make sure you have your asymptote lines dotted in because they are not part of the graph. Whatever is the actual graph, in this case what's in green, you need to have as solid. Letter B, nothing factors, nothing cancels. We know right away that there are no holes. Vertical asymptote. Take and set that denominator equal to 0. We're going to have a vertical asymptote at x equals 0. Horizontal asymptote, we have a degree 1 polynomial over a degree 1 polynomial over a degree 1 polynomial. So we look at the ratio of lead coefficients, y equals 2. X-intercepts, set the numerator equal to 0. 2x minus 1 equals 0. And we get x to be 1/2. So we have the ordered pair 1/2, 0. Y-intercept, plug in 0 for x, we get -1 divided by 0. -1 divided by 0 is undefined, which tells us there is no y-intercept. So let's graph the information we have here. Vertical asymptote at x equals 0. A horizontal asymptote at y equals 2. We have an x-intercept at 1/2, 0. Again, that's not enough points, so we're going to need to pick another one in our xy chart. To the right of that vertical asymptote, we know that we have a point here, which means our graph has to be a smooth curve approaching each asymptote line here. To the left, again, we're not sure whether it's above or below that horizontal asymptote, so pick any value you want to the left. If I put in -1 for x, put in -1 for x, we get -3 over -1, which is +3. So I have a point at -1, up 3, there is our graph. Letter C. Factor this. We get x over x minus 2, x plus 1. This graph, nothing's going to cancel there, so we know it has no holes. Vertical asymptote, take that denominator, set it equal to 0. We're going to have two of them. One at x equals 2, and one at x equals -1. Horizontal asymptote, degree 1 over degree 2, degree 1 over degree 2. Numerator is less than the denominator. That means it's going to be y equals 0. X-intercept, set the numerator equal to 0. Y-intercept, plug in 0 for x. We get 0 over -2, which is also 0, 0. Start sketching what we have. Horizontal asymptote, y equals 0. Vertical asymptotes at x equals -1. And x equals 2. The only point that we know here is we have an intercept at 0, 0. This is going to cause a lot of you problems because you may have been taught in the past that asymptote lines are lines that are approached but never crossed in a graph. That is not necessarily the case. For vertical asymptotes, that is the case. For slant asymptotes, that is the case. For horizontal asymptotes, that is the case only at extreme values. So way out here to the right, we know that our asymptote line cannot be crossed. Way out here to the left, we know our asymptote line cannot be crossed. In the middle, though, there may or may not be a cross of the asymptote line. In this case, we obviously know that there is because we have an x and y intercept at 0, 0. So now we don't know any other information about our graph. We're going to need to make an xy chart and plug in some values here. Again, we are plugging in values in reference to where our vertical asymptote lines are. So let's go to the left of -1. If I go to the left of -1 and put in -2 into this function, we're going to get -2 divided by -2 squared, which is 4, plus 2 is 6, 6 minus 2 is 4. We get -1/2 out. So put a point at -2, -1/2. So that means in this far left section, we're approaching the asymptote line here and here. Let's go to the far right section before we worry about that middle section. To the right, let's plug in +3. If we plug in +3, we get 3 over 9 minus 5, which is 4. We get out 3/4. So over 3, up 3/4. We know in the far right section, our function is approaching the asymptote lines there and there. Now in the middle, a couple of different things could be happening here. We could look like a positive cubic and fall left and rise right through that point. Could look like a negative cubic and rise left and fall to the right. It could come down and touch and go back up. It could come up and touch and go back down. We don't know that, so we're going to need to pick a couple of values. Let's pick positive 1 first. If we put 1 in there, we're going to get out negative 1/2. So we know to the right of this intercept, our graph has to look like this. And now put in a point between 0 and negative 1, so we're going to have to pick negative 1/2. Go ahead and plug that in. When you plug in negative 1/2 and simplify that, you're going to get in the top negative 1/2. In the bottom, negative 1/2 squared is 1/4. 1/4 minus 1/2 is negative 1/4. Minus 2, negative 5/4. Multiply up by the reciprocal, and we're going to get out two-fifths, which means our graph crosses there and approaches in that direction. Last one. Begin the same way. We have a lot of factoring we can do here to see if anything cancels. 2 times x minus 3 times x plus 3. In the bottom, x minus 2 and x plus 2. Nothing cancels. Since nothing cancels, we know right away there are no holes. Vertical asymptotes, set the denominator equal to 0. We're going to have 2 of them again at x equals 2. X equals negative 2. Horizontal asymptote, we have a degree 2 polynomial over degree 2. Anytime numerator and denominator are same degree, we need to look at a ratio of lead coefficients. In this case, 2 over 1, y equals 2. X-intercepts, set the numerator equal to 0. We have 2 x-intercepts here. 3 and negative 3. There's our x-intercepts. Y-intercept, plug in 0 for x. When we plug in 0 for x here, we're going to get 9 in the top. I'm sorry, negative 18 in the top. In the bottom, negative 4. Negative 18 over negative 4 is 9/2. Graph the information that we have. X equals 2 and x equals negative 2. Y equals 2. We have x-intercepts at 3, 0 and negative 3, 0. We have a y-intercept at 0, 4.5. And we should not have to plug in any other points here. We know to the left of this asymptote line, our graph has to approach the asymptote lines in both directions. To the right, it has to approach in both directions. And in the middle, we know since we don't have any other x-intercepts, that this graph has to approach the asymptote lines going up in both directions in a parabola shape.